Let's get back to our class. Okay, we have done example 14. Example 15, I will let you go and view my slides. And if you have question, then come and ask me. All right, this is just another example to test whether it's convergent or divergent. Okay, let's look at another one. Okay, now we go into theorem number 4, which is the truth of mathematics. So if you have two sets of series, now we add series. Don't confuse with sequence. Now we add series. So according to theorem number 4, I label the theorem based on our chapter, based on our module. So if you're having a convergent series, means you have first series A converge, B series also converge. If you have two set of series, means AN means you combine first set. Okay, first set. Then you have second set of number, you combine them also. Then you get BN. So you have AN and BN. Both converge. If diverge, cannot do already. If one of it diverge, then theorem 4 doesn't work. It needs both to be converged. So if you have a multiplication or you have a constant value of C, then what you can do with the operation, you can pull the C outside the limitation or outside the sum symbol. Okay, so you can see the differences between the left and right. So if you have a C inside the AN, you can push the constant value of C outside the sum symbol. Second one, this will be like the law of sum that we learned previously, but this is under theorem 4 that is under series. So this works for series. So if you have two series that inside the bracket of A set plus B set, so A set plus B set, you have two set there. You can push them become two set of summation operation. Okay, you can convert if both in the bracket, you can split them into individual series. And this series is from the series. Once you split the series, you must share the same limit. If you split, I mean outside the bracket, you see n equal to n equal to 1 until infinity. If you split them into two, they share the same 1 to infinity, 1 to infinity. You have constant, you use this equation. You have the bracket between two set number, you use this equation. And you have negative, also doing the same, you just change a negative. Right, positive become negative if you have this negative operation. So this one quite direct. This one will become your Bible already, become your manual that will help you to solve question in test and final exam. Okay, Shakir, are you back?
Yes, sir.
Okay, good. So again, this three green color formula, or we call it theorem, copy somewhere in your note. It will help you to solve question in test and final exam. Okay, because once you write this one out, or you can compare the question and look at all this green color pattern, you will see a pattern, and then you choose one that related to the question. Okay, yeah. So let's look at, since I already tell you, you have three set of possibility or three set of answer, either this one, or this one. So let's look at one example. The question asks you to solve this question. The question 16, again, question 15, example 15, you need to look at the slides later on, later the class, after the class, or after I will upload the slides into Moodle. You go and see the example 15. So just now I skipped example 15, but example 15 is an extra example. If we have time, then we go back. During the revision week, maybe you have time, then I will explain example 15. But you have to look after class, after this or tomorrow or before Monday, you go to Moodle and download the PowerPoint slides and you see. So if the question asks you to solve this question, you have a series, you call it series. The question will show solve this series. Find the sum of this series. So you know that this one is series. This one is series. Okay, so again, the question, how many set of series you have here? Nizam, how many set of series you have? How many set of series you have?
One, sir.
One is this one. Another one?
That's two.
So, can you see the pattern, this one and this one, to the previous slides? Yeah, which one? Which one? Which one you choose? This one, or this one?
Second one.
Second one. So, you choose this second one. You copy this equation in your answer sheet. You get 1 mark. Huh? It's very easy to score in my module. You give me the correct equation, I give you marks. But you don't 3 also copy. You put this 3 copy means I know you don't understand and you just tikam lah. So again, it's easy to score in our module, but you don't copy everything in your answer. I know if you copy everything means you tembak. You don't know which one is the correct one. You won't get marks if you copy everything in your answer. Okay, I know if you copy 3, you put your answer, I won't give you marks because I know you don't understand. So you look at the question, then you pick which one, first one, second one, third one. So in this one, you know is a second one because you are having 2 set of series, AN and BN. So you combine, you copy this one, put under the question, you compare side by side. You're able to see this one is your AN, this one is your BN, correct? Then you do as what you learn in the calculation just now. You solve this set, combine the answer together, you get the final answer. Right? So this is just an application of theorem. So you know your AN, this one, equal to this one. Your first set is this one, AN. BN equal to this one. So you split the operation, you solve this one. After that, you solve this one. You combine the result together, you get the sum of this series using theorem. Using theorem. So yeah, basically you write this equation, you get 1 mark. You copy, you substitute, you tell me that, okay, you understand what is AN. You substitute this one inside here. AN equal to this one, you substitute this one here. BN equal to this one, you substitute here. This one gives you second mark. First point, 1 mark here, 1 mark here. The rest is just to test you whether you know how to solve this series or not. You know how to solve this kind of series or not. Okay? Then the third step, you know this kind of pattern. This set, you can use the first theorem. This one. You know that there is a constant that you can push outside the sum symbol because this is a C times AN, means the constant value can push outside. So when you come to this step, you know that this one is a constant value. It's a constant value. You push number 3 outside the sum here. You write 3 summation 1 divided by n times n plus 1 plus 1 over 1n. So this is the pattern that we always want you to get. So you try to see, actually in mathematics is fixed already. The SOP is fixed already. As long as at the end you get 1 above, then you are safe. Okay, then the n below, never mind lah. Okay, as long as top one you get 1, then you are safe. Okay, from here, okay, from the question to here should be no problem, right? Edmund, you understand, right? Why you use this one and then arrive at this one and this one. Edmund, you understand, right?
Yes, sir.
Okay, good. So, okay. So you have the question ready. So just now, example 12, we already solved this one. Okay, just now example 12, we already solved this one already. So you refer to the answer. You know that just now example 12 equal to 1. Okay, again, if you can't remember, just refer back to the previous PowerPoint slides. Or you can, if you're watching YouTube now, if you don't remember this one, just rewind the video and go and find this question, example 12. Now we look at this one. How to find this series? This one, you use the procedure. Okay, you use the procedure. Okay, how do I explain this one? Okay, how do you solve this question by using the equation that we learned just now? Let me pull out the general equation. Actually, we just use back the general equation. Give me some time to rewind back my slides. Okay, this one. Still remember this one just now? Because we are having geometric series. So you take A divided by 1 over R by looking at if you are having geometric series lah. Okay, or if not, then you have to refer back to the previous lecture. There is a general equation to calculate that one. So let me fast forward a little bit back to example. Okay. There's one example to solve this question. Can you see that this one is half? If you write this one in exponential, you know that this one is 2 power negative n. Can you see? This one actually is 2. If you write this whole equation, expand in the exponential, you can get this one is 1 times 2n minus 1 times 2 negative n. Then you use the formula just now. Okay. If you use the formula, what happened? The top one is A, right? A divided by 1 minus R, right? A divided by 1 minus R. How you know the A is half? A is the first number. So you substitute your n equal 1 as first number. First number always n equal 1. So 1 over 2, n is 1, so you get half. How you get R? R is the ratio of the number. You just take, how you find R? R, you take the second number divided by first number, or the third number divided by second number, or the fourth number divided by the one that before it, which is the third number. So the most simpler way, you take the second number divided by first number. So how to get R? What is your second number? 1 over 2, n equal 2, so 1 over 2 power 2, which is 1 over 4. Can you see the second number of this equation is 1 over 4? Edmund, can you see it? Why I say the second number equal to 1 over 4? What is the second number? The n number will be 2, right?
Yes, sir.
So 1 over 2 power 2, what do you get? 1 over 4, right?
Yes, sir.
So you want to find the R, the ratio of the geometric equation. You want to find the R, this one. How you get 1 over 2? You take the second number, divide by the first number. So what is the second number? I already calculate for you. Second number is 2. So 1 over 2 power 2 is 1 over 4. What is the first number? N equal 1. So 1 over 2. You take 1 over 4, the second number, divided by the first number. 1 over 4 divided by 1 over 2. What do you get? 1 over 2. Get it? Shakir, you get it? Or you need me to explain one more time how you get 1 over 2?
So can you repeat?
Okay. Nizam, you okay? Nizam, you okay to get this one? Are you all right? Do you understand how to get R?
R, I got it. But then
Ah.
up, you said A over 1 minus R, right?
Yes.
Okay, so A just now you told 1.
No. A
Yes or
is
no?
not 1. A is not 1. A.
Yeah.
Oh,
A is supposed to be the first term, right?
yeah, first number. So you see, this is your equation. Your series equation is what? 1 over 2
1 over
power n, right?
yeah.
So what is your first number? First number n equal what?
Half.
No. 1. 1. N equal to 1 is the first number. So you get
So 1
1.
over 2 is the first number.
No, how you get the first number? You always replace n equal 1. How you know if you're given the first equation, the equation for the series, how you get the first number? N equal always 1. You substitute n equal 1, you get the first number.
Yes.
If you get the second number, how you get second number? N equal 2. So you get 1 over 4. How you get the third number? N equal 3. So 1 over 8 and so on. So how you get this calculation? Because you see this one as geometric symbol, as geometric series. And just now, geometric series, you know that, this is theorem. Geometric series, it gives you one equation, just now. Okay, just to add on. So even you're given an equation, how you get the first number of the equation? You just substitute n equal 1, then you get the first number of this equation. How you get the second number of this equation? You substitute n equal to 2, and you get the second number. How you get the third one? Substitute all n equal 3 in whole equation, then you get the third number. Okay, let me flip to the slides. This one. This is geometric equation. So if you have a geometric equation or data, you can use this one and this one. So you know that if you're able to write the pattern of the numbers or the equation, you can rewrite them in this pattern, AR power n minus 1. The sum of the answer is A divided by 1 over R. So how do you get A? How do you get A? Is that you use the equation or given, this is a general equation for geometric series, but you have many kinds of data that give you one equation. So just now you see 1 over 2 power n. So this one will be the equation that we'll be using. So how do you get the first number? You just replace n equal 1. Then you get the first number. That's why this set of geometric, that's why the first number is A. So you don't confuse why suddenly here is A and then why suddenly in the tutorial question there become half. So because of the equation, it changed already. But the concept is important. You need to remember n. N is the position of the number. If you want to look for first number, n equal 1. If you want to look for second number, n equal 2. You just substitute inside the equation given. Then, if you know that you can rewrite in the equation that given in the question, you rewrite in the AR n minus 1 pattern, you know, and you prove that actually is a geometric series, then you can, and the question asks you to add all the number together in the geometric series, you can use this equation, A divided by 1 over R. How you find R? R is the ratio, you take the second number divided by the first number, or if you're hardworking, you can take the second number, third number divided by the previous one, the second number, or the fourth one divided by the third one. So normally we take the second one minus the first one, not minus, divided by the first one, you get the R. Again, how to find the second number and the first number? Just change the n inside the equation. All right, so we go back to the example. Go back to the example. Those watching YouTube, you can just fast forward. Okay. Okay, so that's why we can say this is a geometric pattern. I already skipped the geometric general equation, but I know that this one is geometric pattern. So that's why I can use the general equation to get the sum of the geometric equation. So the first one is A. How do you get A? A is the first one, right? So n equal 1. So 1/2, you get the 1/2 here. So this one, you know that in the general equation, this one is A divided by 1 minus R. This is R. How to get R? You take the second number divided by the first number. So 1/2 power 2 divided by 1/2 power 1. So basically you take 1/4 divided by 1/2. So basically it's 1/2. So here 1/2 divided by 1/2, what do you get? What do you get, Edmund? What do you get? Half divided by half, what do you get? 0.5 divided by 0.5, what do you get? Edmund? 1. You get 0.5 divided by 0.5. 1 minus 1/2 is 0.5. 0.5, 0.5, you get 1. So the first set, you get 1.
Second set, 1.
1. So what do you get? What is the final answer from here?
1, 2.
2. So the answer is 2. Not 2 lah, but you have to, let's see, yeah, correct. But remember just now you have pulled the 3 outside, right? Yeah. Remember you have pulled the 3 outside. So yeah, this is also one of the mistakes done by student. Once you pull out, you have to remember you pull the number out. And actually the general equation we use is actually 1 over n plus this one, multiplied by this one. But because we already done the first one in example 1/2, so we just recycle the answer. We just push the 3 in front, and then what we want always in our solution is the top one will be 1. Okay, so 3 multiplied by 1, because this whole set is 1, plus this one is 1, so the answer is 4. Okay, answer is 4. So this is how you do it lah. So actually the concept is easy. It's only you need to do more practice lah. You need to do more practice and then familiar. How do you move number around? Okay, how do you move number around? The concept actually is very straightforward. It's only don't confuse yourself with all the exponential or all the numbers. Okay. Yeah. So this is how you find the sum for the series. Next lecture, we'll see this one next lecture. This is our main focus. There will be one question come out for power series. Okay. So test 1, you will have one question in this power series. So I already spent time this whole week. Already tell you, already polish you what are sequence, what are series. Next lecture, we're going to combine what we learned previously, combine the concept to solve power series. Okay, so we will talk about power series in next lecture. Okay, let me end the recording.